Hello everyone, welcome to the video tutorial on cryptography and network security. So today I am going to discuss another important topic from the module number 1, that is block cipher design principle. Already we know that in the symmetric algorithm we use two types of principles. One is block cipher, another one is stream cipher. So all these things I have explained in class, that is stream cipher, what is there in the stream cipher, and the block cipher. So we have seen the algorithm called as DES algorithm, which uses the block cipher method. Okay, so here in the block cipher method, so it will take the plain text. So plain text, the plain text will be divided into number of blocks. Depending on the size of blocks, we will take it. So sometimes the size of the block may be 40 bits, or we may consider 64 bit, 128 bits, like this it goes on, but we usually have seen 64 bits block in the DES algorithm, which we have already studied. So the plain text is divided into number of blocks. So then each block will be then XORed with the key which is given there. So we'll do some permutations or their initial permutations and all these things which we have explained in the class. And then after doing all these things, it goes up to 16 rounds. So up to round 1 to round 16. So where the bit positions will be changed, that is called as transposition rules. So according to the transposition rules, so the rounds will be taken, and then after the end of 16 round we will get the cipher text. So all these things we have studied. So this rounds are there because this DES algorithm uses Feasel structure. Already we have studied Feasel structure. So because of Feasel structure, the initial key, initial plain text, then the key which we have given is undergoing into the rounds, where each round will generate a sub key. So there are totally 16 rounds. That means 16 sub keys will be generated here. So these rounds are there because the DES algorithm uses Feasel structure, because in Feasel structure it contains the rounds. Okay, so some algorithms, so here since it is a DES algorithm takes 16 rounds, there are some algorithms which also takes 10 rounds, or some algorithms will take 20 rounds, like this. It depends on the algorithm which we are using. Okay, so let us see what are the block cipher design principles. So you can see here in a block cipher, the plain text is broken into number of blocks of a set length. So as I already discussed, we have seen the length of block as 64 bit in the DS algorithm. So the plain text is divided it or broken into number of blocks, and each of blocks will have certain size. So for example, our DES algorithm is having 64 bit, and then bits of each blocks are encrypted together by using the function and key to produce the cipher text. Several block cipher design principles are listed and explained below detailedly. So these are the some block cipher principles. So first one is block size, next is key size, round functions, number of rounds, subkey generation, and fast software encryption or decryption, and ease of analysis. So these are the rules, or these are the principles which are available in the block cipher design. So first let us see what is block size. So we know that the plain text is divided into number of blocks. So if you increase the size of blocks, the complexity will increase. So suppose for example from 68 bit to, if I increase to 124 bit, then the complexity increases. Okay. So if we improve the complexity, or if the complexity is increased, then it is having more security. Even though it is complex, but it is very secure. Okay, so the algorithm may work slower. The algorithm may work slower, but it is very secure. Okay, it is very secure. So because we have increased the block size, that means so the complexity will increase, but the security level is also very good. So if you decrease the block size, then the algorithm works very faster, but the security may not be there. Okay, that's the case. So increase the block size may increase the complexity, but it also improves the security. Right. So second part is key size. So as we know, key size in our DS algorithm is 64-bit, and then it is converted into 56-bit. So if we increase the key size also, then also our complexity will increase. Our complexity will increase, but it is very hard for hackers or attackers to attack for the key, because so if we increase the size of key, then complexity will increase. If it is very complex, then it is very hard for attacker to check or to know what is the key that we are using. So it is very hard to search the key. So if you increase the size of the key, so this is another important thing. Next is round function. So as we know that our block cipher algorithm uses Fiesel cipher methods or Fiesel structure, where number of rounds will be there. So suppose for example, if we consider DS algorithm, 16 rounds were there. So as we increase the round, so same thing again, complexity will increase. Okay, the performance may be slow down, but when we consider security point of view, the security is improved. So we will have more security when it goes to more number of rounds. So even the algorithm performance may decrease, or algorithm may slow down to generate a cipher text, but the security will be increased. This is very very important. So in every cases here, so when you increase the key size, when you increase the block size, when you increase the round, everywhere the the algorithm may slow down, the algorithm execution will take more time, but it increases the security. This is very very important to understand here. It has the issues of how yes boxes are selected. So it is also having some issues with yes box, how to select the yes box. Next, number of rounds. This is already over. Number of rounds. So as I said, increase the number of round will increase the complexity, but also it improves the security. So next, more number of rounds slow down the cipher performance, as I already told. If you go to more than, so for example we have 16 rounds, if we increase to 20 rounds, then the performance may be slowed down, but the security will be very higher. Okay, so typically we are using 16 rounds for encryption and decryption. So next, subkey generation. So as we know that each round will generate one subkey in the DES algorithm. So total 16 rounds are there, that means 16 subkeys will be generated. And so it will be very harder if we increase the rounds. Okay, for example I increase it to 32 rounds, then the subkey generation is also very very harder, because we need to generate that many subkey. So the algorithm may become complex, the algorithm may becomes complex, and the algorithm executes slowly. But as I said, if it is slow also, the security is very much, the algorithm is very secure. The attackers cannot attack your key or cannot attack the plain text. And then fast software encryption or decryption and ease of analysis. The speed of software encryption or decryption and ease of analysis are more recent concern for the practical use in Cipher. We have to keep in mind these aspects while performing the testing on Cipher, because see everything, if we increase we get more secure. Okay, security is not a concern. So if we increase key size, if we increase block size, we will get more security. But also we need to keep in mind that the performance, okay, previously the performance was slowed down. Okay, but we don't want the performance to be slowed down. We want most secure, but the performance is very very fast. The performance will be very very fast. The algorithm should execute very very fast. In this way we need to design the algorithm. So what our previous algorithm is doing is, if we increase the block size, if we increase the key size, definitely the security is there, but the performance was very very slow. So we need to develop a algorithm in such a way that even though we increase the size, we increase everything, it should not affect the performance. The performance should be very very good, and it should be more secure. So in that way we need to design the algorithms. So this is nothing but, so all these things are the aspects of the block cipher designing principle. So please go through this video once again, understand all the concept clearly because it is very important. And with this, I completed the module number 1. Okay, with this, the module number 1 completes. So thank you very much. Please go through all the PPTs and all the notes. Thank you.